What if I told you that the future of private aviation doesn't just fly faster, it flies smarter, farther, and with half the fuel of today's most advanced business jets? Imagine boarding an aircraft with no traditional passenger windows, a futuristic digital cabin, and an aerodynamic design so efficient it looks like it came straight out of a science fiction movie. Most people have never heard of it, yet this revolutionary aircraft could completely change the aviation industry. This is the Otto Aviation Phantom 3500, a jet that promises to rewrite the rules of flight. But can it really deliver on those incredible promises, or is it simply another ambitious dream? Stay with us until the end because the technology behind this aircraft is unlike anything you've ever seen. For more than 70 years, aircraft designers have followed nearly the same formula. Long cylindrical bodies, rows of windows, large wings, and engines mounted under or behind those wings have become the standard design for modern airplanes. While engines have become quieter and more fuel-efficient, and avionics have advanced dramatically, the basic shape of airplanes has remained surprisingly similar. The reason is simple. Aircraft manufacturers must balance safety, efficiency, passenger comfort, manufacturing cost, and certification requirements. Changing one part of an airplane often creates unexpected challenges elsewhere. Because of this, aviation evolves slowly compared to industries like automobiles or consumer electronics. But every once in a while, a company appears with an idea bold enough to challenge decades of accepted engineering. Otto Aviation is one of those companies. The Phantom 3500 is not simply another business jet. It represents an entirely different philosophy of aircraft design. Instead of asking how to make existing airplanes slightly better, Otto Aviation asked a much bigger question: what if we redesigned everything from the ground up? That single question led engineers toward one of the most unusual aircraft concepts seen in modern aviation. The first thing people notice is the aircraft's incredibly smooth fuselage. Unlike conventional jets covered with dozens of passenger windows, the Phantom 3500 features an almost seamless exterior. At first glance, many people wonder if passengers would feel trapped without windows. Surprisingly, the answer may actually be the opposite. Traditional aircraft windows create structural weak points. Every window requires reinforcement around the opening because cutting holes into the fuselage reduces its strength. That extra reinforcement adds weight. More weight means more fuel consumption. By removing conventional windows, engineers can build a lighter and stronger pressure vessel. Instead of looking through glass, passengers experience panoramic ultra-high-definition digital displays that recreate the outside world using advanced external cameras. Imagine sitting in your seat while the entire cabin wall transforms into a live cinematic view of mountains, oceans, sunsets, or city skylines. This technology could even display flight information, weather conditions, or customized environments during the journey. But the windows are only the beginning. The Phantom 3500 is designed around one of aviation's greatest challenges: drag. Whenever an airplane flies through the atmosphere, air pushes against every surface. This resistance, known as aerodynamic drag, forces engines to burn more fuel. Engineers have spent decades reducing drag by refining wings, reshaping noses, and improving engine efficiency. Otto Aviation believes they can reduce drag far beyond conventional aircraft by creating an extremely smooth airflow over the entire airplane. Their design philosophy revolves around maintaining what engineers call laminar flow. Under normal conditions, air flowing across an aircraft quickly becomes turbulent. Turbulence increases resistance, reducing efficiency. Laminar flow keeps air moving smoothly over much larger portions of the aircraft, dramatically lowering drag. Maintaining laminar flow isn't easy. Even tiny imperfections, small dents, insects, dirt, or rough paint can disturb the airflow. That's why engineers devoted enormous attention to the aircraft's outer surface. Every curve has been carefully shaped using advanced computational fluid dynamics. Thousands of computer simulations helped optimize every inch of the airplane. The result is an aircraft that appears almost sculpted rather than assembled. Its elegant nose gradually blends into the fuselage with no unnecessary protrusions. The wings stretch gracefully from the body while minimizing airflow disturbances. Even the engine placement was selected to reduce aerodynamic interference. If Otto Aviation's calculations prove correct during real-world operations, the Phantom 3500 could consume dramatically less fuel than today's competing business jets while maintaining impressive speed and range. Fuel efficiency isn't simply about saving money. Aviation contributes a significant percentage of global carbon emissions. Every kilogram of fuel saved reduces environmental impact while lowering operating costs. Business aviation has often faced criticism for its emissions compared to commercial airlines carrying hundreds of passengers. Otto Aviation hopes their design changes that conversation. Imagine a business jet capable of traveling thousands of miles while burning nearly half the fuel required by similar aircraft today. That level of efficiency would transform corporate travel, government operations, medical transport, and even future regional aviation concepts. Of course, extraordinary claims require extraordinary proof. Throughout aviation history, many revolutionary aircraft concepts have looked incredible on paper but struggled during testing. Engineers must overcome countless obstacles before certification. Aerodynamics, structural integrity, manufacturing precision, maintenance requirements, pilot training, emergency systems, cabin safety, and regulatory approval all present enormous challenges. Even maintaining laminar airflow in everyday airline service may prove difficult. Real airplanes encounter rain, dust, bird strikes, hail, and constant wear from thousands of flight hours. Can such an advanced surface remain perfectly smooth throughout years of operation? That remains one of the industry's biggest questions. As development continued, Otto Aviation engineers realized that achieving exceptional efficiency would require more than simply designing a beautiful airplane. Every component had to contribute to the same goal. The wings were carefully optimized to generate lift while producing as little drag as possible. Their shape was refined through thousands of digital simulations, each one testing how air would flow over the aircraft at different speeds, altitudes, and weather conditions. The engines were mounted at the rear of the aircraft, a choice that helps preserve smooth airflow over the wings and fuselage. This configuration also reduces cabin noise, making the passenger experience quieter and more relaxing. For business travelers who spend hours working during flights, a peaceful cabin can be just as valuable as extra speed. Inside, the Phantom 3500 promises a completely different experience from traditional business jets. Instead of feeling confined by small oval windows, passengers could enjoy ultra-high-definition digital displays that recreate the outside world in real time. Cameras mounted around the aircraft capture panoramic views of the sky, mountains, oceans, and cities, displaying them across the cabin walls. The result could feel more immersive than sitting next to a conventional window. The aircraft is also designed with sustainability in mind. Fuel is one of the largest operating expenses in aviation, and reducing consumption benefits both operators and the environment. If Otto Aviation achieves its performance goals, companies could save millions of dollars over the lifetime of each aircraft while significantly lowering carbon emissions. Of course, transforming a revolutionary concept into a certified aircraft is never easy. Aviation authorities require years of testing before approving any new design. Engineers must prove that every system performs safely under normal conditions and extreme emergencies. From high-altitude pressure tests to lightning strikes, crosswinds, heavy rain, bird impacts, and engine failures, every possible scenario must be evaluated. This is where many ambitious aviation projects face their greatest challenge. A concept may look extraordinary in computer simulations, but real-world testing often reveals unexpected problems. Small changes in airflow can affect stability, handling, and efficiency. Engineers must constantly refine the design until every requirement is satisfied. For Otto Aviation, one of the biggest goals is maintaining laminar airflow during everyday operations. Even tiny imperfections such as insects, dirt, ice, or surface damage can disturb the smooth airflow that makes the aircraft so efficient. Developing maintenance procedures that keep the aircraft performing at its best will be just as important as designing the aircraft itself. Despite these challenges, the Phantom 3500 has attracted significant attention across the aviation industry. Engineers, pilots, investors, and aviation enthusiasts are watching closely because the aircraft represents something that has become increasingly rare: a completely fresh approach to aircraft design. Instead of making small improvements to existing business jets, Otto Aviation is attempting to rethink how an airplane should be built from the ground up. For passengers, the benefits could be remarkable. Longer non-stop flights, lower operating costs, quieter cabins, and a futuristic travel experience could redefine expectations for private aviation. Business leaders could travel farther without refueling, governments could operate more efficiently, and emergency medical organizations might reach distant locations faster than before. Even if every goal is not fully achieved, the technologies developed during the Phantom 3500 program could influence future aircraft for decades. History has shown that innovations introduced on one aircraft often find their way into many others. Composite materials, winglets, fly-by-wire controls, and advanced avionics all started as revolutionary ideas before becoming industry standards. The Phantom 3500 may follow a similar path. Its emphasis on aerodynamic efficiency, digital passenger experience, and lightweight construction could inspire manufacturers around the world to rethink their own designs. And perhaps the most exciting part is this: aviation is entering a new era. With advances in artificial intelligence, sustainable fuels, hydrogen research, electric propulsion, and revolutionary aircraft shapes, the next generation of airplanes could look very different from the ones we fly today.